Hello class 9th and happy new year and welcome back to online classes after winter holidays. Children, today in this video I'm revising chapter 5 that is your periodic table. As some of you are requesting me to revise this chapter, so let's start the revision of chapter 5. Okay, now revision of periodic table. All of you know that there are total 118 elements were discovered till today's date, and to make their study easier, we arrange these elements in a tabular form, and that tabular form is called what? Periodic table. Many early chemists, they tried to classify the elements on the basis of their properties, valencies, metallic and non-metallic nature, but they were failed to classify the elements in a proper sequence, right? Then in 1815, Dobernier, he arranged the elements in increasing order of their atomic weight in a group of 3 that is called what? Triads. So who gave triad? That is your Dobernier. And he gave a law that is called Dobernier's law of triads. And what was his law? Chemically analogous elements. Analogous means the elements which are having a similar properties. Okay, they arranged in an increasing order of their atomic weight. They formed well-marked group of 3 that is called what? Triads, in which the atomic weight of the middle one is the average weight of the first and the third element. But this classification was also discarded because the properties of elements grouped into triads were found not to be similar for all the elements, right? Then Newlands in 1864, he also tried to classify the elements, and he arranged the elements in increasing order of atomic weights in series of 8. And actually he arranged the elements on the basis of the musical note, that is give a law that is called Newlands Law of Octaves. Now what was his law? He just showed that elements when arranged in increasing order of their atomic weights show resemblance in physical and chemical properties between the 8th element and the first element, just similar to the 8th and the first note on musical scale. As just you know that sa, re, ga, ma, pa, dha, ni, sa means first and the second again the sa is coming, means the properties of sodium are similar to the properties of lithium, means here repetition of properties occur with the first and the 8th element, right? And that's why he gave his law name, that law of octaves. But method was also discarded because this method is also not meaningful for the heavy metals, right? Then Mendeleev in 1869, he arranged the elements in increasing order of their atomic weight in the form of a table, and that table is called periodic table. And then he gave a law, that law is called Mendeleev's periodic law. And what was the law? The physical and chemical properties of elements are periodic function of their atomic weight. Means he arranged the elements in their increasing order of atomic weight, right? And the physical and chemical properties of elements are periodic function of their atomic weight. Now, so what was the contribution of Mendeleev regarding modern periodic table? Actually, what was the contribution? Contribution means what was the gift of Mendeleev towards the modern periodic table, or towards the modern classification of elements? First is your Mendeleev arranged the elements in increasing order of atomic weight in horizontal rows, and what these rows are called? Periods, right? And vertical columns are called groups. What the vertical columns are called? Groups, and horizontal lines are called what? Periods. Then elements which are similar with respect to their chemical properties, they are grouped in a group together and have atomic weights of nearly the same value, means those are grouped in same group, they have similar chemical properties. So next is your elements in same group, they have same valency and similar chemical properties. Next contribution is here, what based on the periodicity of properties. What is the meaning of periodicity of properties? Periodicity of properties means repetition of properties after certain interval. A number of gaps were left in the table for undiscovered elements. And next is here, the properties of the undiscovered elements left in the vacant gaps was predicted. Prediction meaning he forecast their properties before they were discovered. They were predicted at that time only by the Mendeleev when they were not discovered. Okay, and in some of the elements whose atomic weights were not correct, they were also corrected with the knowledge of some atomic weights of the adjacent elements. But there were again some defects and anomalies in Mendeleev's periodic table. And what was the main defects? First is your anomalous pairs of elements. Means Mendeleev arranged the elements in increasing order of their atomic weights. But certain pair of elements having higher atomic weights have been given position before the elements having lower atomic weight. For example, cobalt having atomic weight is 58.9. was placed before nickel, whose atomic weight was 58.6. So these pair of elements are called anomalous pairs of elements. Right? First defect. Second defect is your position of rare earths and actinides were not justified. And third defect is your position of isotopes were also not justified. Because actually what are isotopes? These are elements having same atomic number but different mass number. So if they have a different mass number, that means they have to give different places, right? But that's why we can say that position of isotopes were not justified. But when this classification was based on increasing atomic number, then their position was justified. Then Moseley gave a modern periodic table, right? And he arranged the elements in the increasing order of their atomic number. In place of atomic weight, he arranged the elements in increasing order of atomic number. So what was the basis of his classification? That is your atomic number. And same, he arranged the elements in increasing order of the atomic number, and he make a 7 horizontal rows, what he called periods, and 18 vertical columns were there are there in the periodic table. That is called these columns are called groups. And he gave a modern periodic law, that is called the physical and chemical properties of elements are periodic function of their atomic number. Periodic function meaning when any property, whether it is chemical or physical, it repeats after a fixed interval of elements. Okay, now what was the reason for periodicity in properties? Okay, when he arranged the elements in increasing order of atomic number, he found that there is a similarities in properties after regular intervals, and then he gave a term periodicity in properties. Though what is the meaning of periodicity in properties? Means repetition of properties after regular intervals. So why there is a repetition of properties? Because after definite interval of atomic number, reoccurrence of similar electronic configuration takes place. Right? Because lithium atomic number is what? That is your 3. And below it what comes? Sodium, its atomic number is 11. So their electronic configuration is same. 2, 1, and it says 2, 8, 1. Right? And since properties of elements are depend on number and arrangement of electrons, including your electron in the valency shell, means the chemical properties are depend on this valency electron. And because valency electrons are similar in a group, that's why their properties are also similar. Next is what are periods? Periods are 7 horizontal rows of elements arranged in increasing order of atomic number are called periods. Or simply 7 horizontal rows of elements in a periodic table are called periods. And period number signify number of electron shells of an element. If suppose, for example, this lithium atomic number is 3. So their electronic configuration is 2 1. Right? So how many shells are there? 2 shells are there. So it will come in second period. So next is your sodium. Sodium atomic number is 11. So how many shells are there? Its electronic configuration is 2 8 1. So 3 shells are there. So it will come in third period. So period number signify number of electron shells of an element. Right? This first period is called the shortest period because there are only 2 elements in the first period. Second period and third period having 8 elements in these second and third period, and they are called short period. Now then main what you have to learn the elements of period 1, 2 and 3 only. Learn these these elements in their increasing atomic number. Right? Now just look at the properties of trends in a period. Just look in periods. Actually, if you see the atomic number is increases by 1. Our electronic configuration also increases by 1. Here lithium 3 atomic number, electronic configuration 2 1, then 2 2, then 2 3. So what's happened? Number of electrons or valency electron increases by 1 when you move from left to right. Right? And state state wise means in which state the first 2 matters, that is your lithium and beryllium, they are matters. Then boron is a metalloid of period 2. Name the metalloid of period 2. That is your metalloid. That is your boron. Non-metal is your. Then after that, rest all are non-metals. And then the last one is your noble gas, because 18 group elements are actually called what? 0 group elements, or they are noble gases. So first matters are there, then metalloid, then non-matters, and then noble gases. And their valency, first element, that is your lithium, sodium, they have 1 valency. Then second group elements having 2. Then 13 is having what? 3. 14, 4. Then 15, 3. Then 16, 2. Why? Just remember, because it has what? It will lose 1 electron. So its valency is 1. This beryllium lose what? 2 electrons. So its valency is 2. Then boron, it's lose 3 electrons. So its valency is 3. Carbon has 4 valency electrons. So neither it will lose nor it will share. It will gain. So what it will do? It will take sharing, and its valency is plus minus 4. Now come to nitrogen. Atomic number 7. Electronic configuration 2 5. So what it will do? To get a stable electronic configuration, it will gain 3 electrons to get a stable electronic configuration. So its valency is minus 3. Right? Then oxygen atomic number is 8. Electronic configuration 2 6. So it will gain 2 electron to get a stable electronic configuration. So its valency is minus 2. Fluorine, atomic number 9. Electronic configuration 2 7. So what it will do to get a stable electronic configuration? It will gain 1 electron. So that's why its valency is minus 1. But noble gases, they have stable electronic configuration. So neither they lose nor gain or share the electron. That's why their valency is 0. Right? Same way in period 3. Name the metalloid of period 3. That is your silicon is the metalloid of period 3. Gas of period 3 is your argon. So what is the property trend of elements from left to right in a period? That is your number of electron shell remains same. 3 3 3. The number of electron shell remain same, but a valency electron increases by 1. Right? Now come to groups. Group is what is group? Group 18 vertical columns in a periodic table are called groups. Right? And there are total 18 groups are there. Group 1 elements. What group number signify? Group number signifies the number of valency electron of an element. If it belongs to first group, its valency electron is 1. If it belongs to second group, if any element belong to second group, its valency would be 2. If it belong to 13, then 3. If 14, then 4. If 15, then 5. Then 16, valency electron is 6. So group number signify the number of valency electrons. Now come to group. First group elements are called alkali metals, right? Why they are called alkali metals? Because they form strong alkalis when react with water. And first alkali metal of is your lithium, that is your light metal. Okay, second is your what? Lithium, then sodium, then potassium. Okay, group wise. Now second group elements are called alkaline earth metals, right? Then 3 to 12 are called transition elements. What they are called? Transition elements. And 13 to 16 are called post transition elements. And 17 group elements are called halogens, and 18 group elements are called noble gases or inert gases. Now, what is the property trends of elements on moving down in a group? Just remember, if you just look at this first group, here number of shells increases by 1. Okay, so what you will say, when you move from top to bottom, when you move down, then valency electron in what is same, but number of shell increases by 1. In period, just remember, in period, number of shell remains same, but valency electron increases by 1. But in a group, valency electron remains same, but what number of shell increases by 1, right? And because valency electron remains same, that is why their chemical properties are similar. So look at this modern periodic table. First group elements are called alkali metals. Second group elements are called alkaline earth metals. Then 3 to 12, they are called transition elements, right? Then 13 group is called what? 13 to 16. But they are called 13 to 16 are called post-transition elements. 17 group elements are called halogens, and 18 group elements are called these are inert gases or noble gases, right? Then what is the position of lanthanide series? It come in 6th period. Lanthanide series come in 6th period, and actinide series come in 7th period. And what is the, sometime question may ask, what is the position of radioactive elements in periodic table? That is your 7th period contain radioactive elements. Okay, thank you children.